Hi, we will see now probability sampling techniques. There are two methods of sampling. One is non-probability sampling, which is used when the sampling frame is small, that is population size is small. Another is probability sampling. We are going to see probability sampling techniques now. In any population, we are interested in any of the two characteristics. One is qualitative, another is quantitative. First, we will see qualitative. Proportion of population with a character of our interest. Suppose we want to find out the proportion of good people in a population. We take a sample, say 30, and 20 out of 30 are good people. Then this is a sample statistics, and we can estimate the population parameter based on this. The second one is average value of a character of our interest in our population. This is like average salary, average weight, average height. See, average salary is 12 lakhs per annum per family. We do a sample study to determine the true parameter value of the population from the sample characteristic value. Please note, population characteristic is called parameter because it is fixed and it doesn't change. And sample characteristic value, we are getting it from the sample that we collect from the population. This is called statistic. So we estimate the population parameter from the sample statistic. Sample size is the optimum number of observations from the population you intend to study. Why should it be optimum? If it is too low, it will be biased. If it is too high, it will be time consuming, it will be costly. As the population increase, sample size required also increases to cover the entire range. Now, for example, you see this is the population, the dark brown arrow, dark green arrow is the sample size. Suppose the population is large, then sample size also is large here. It also depends upon the variability in the population. As variability increases, the sample size required becomes more to cover the entire variability. We will visualize this also. So this is a population, it has a low variability, that means low standard deviation, low variance, low coefficient of variation. And therefore sample size is low here. In this case, the population has got a high variability, therefore sample size will be higher in this case. Margin of error, this is the accuracy from the true value within which the population value lies. Suppose I conduct a sample study and estimate the population mean to be 50. If the margin of error is 2%, the population mean lies between 48 and 52. Suppose I want the margin of error to be 1%, 49 to 51, I want the answer. Then the precision is more now, the sample size required also will be more. So as you need more precision, the sample size required becomes more to get the required accuracy. That means I have to increase the sample size to get a lower accuracy than this. As you want to become more confident in your results, you increase your confidence level. Suppose I want to increase my confidence level. Then what happens? The error will increase. As you increase your confidence level, the accuracy decreases and the margin of error increases like this. So it has become increase. Error becomes more. Steps involved. Step 1 is identify sampling frame. This is nothing but the population size. Step 2 is decide sample size. We need to have three values to determine the sample size. One is the population size, another is confidence level, third one is margin of error. Step 3 is choosing sampling technique. Step 1, identify sampling frame. It is a complete list of all cases in the population from which our sample will be drawn. So this is represented by capital letter N. Step 2 is decide sample size. It is denoted by small case letter, lowercase letter n. If sample frame is less than or equal to 50, that is population is less than or equal to 50, bias may occur in the sampling, so probability sampling will not be used. So you will go for non-probability sampling technique. Your sample size should be at least 30. So we should know the population size here first. Then confidence level we'll have to fix. Say, suppose we fix 95% confidence level. Level of confidence is 95%. What does it mean? If I select 100 cases in my sample, then 95% level of confidence means at least 95 of these cases will represent population parameter. Margin of error, it is accuracy. It is accuracy you require for any estimate made from your sample. So it will be say 33% to 5% normally. We will fix it. Margin of error, we are fixing it. Now we will take a template, Excel template, and then find the sample size. This template is attached to the description. You can download and use it. I will explain how it is to be used. See, there are 7 methods are there, depending upon what data you have and what characteristic you want to study. You can substitute the values and get the answer. You can also check the answer by substituting the values data in the formula given side by side. Now, first case is Yamane's formula. Here only population size is known. Suppose they make it as 50,000, then sample size is only 1087. In this, we are assuming the level of confidence as 95% and margin of error 3% to 9% here. For 3%, sample size is 1087. For 9% margin of error, it is 123 only. And the second qualitative sample study is using coherence formula. Here we are changing the level of confidence. Instead of fixing it as 95%, we can change it. And for different margin of error, we can find out the sample size. And the population size, if I fix, say 50,000, then you can get a different sample size. This again is using the formula given on the right hand side. Method 3 is for quantitative sample. Here the sample size will be a little larger. We are giving the standard deviation of the population and level of confidence 95%. And then we can change the population sizes to 50,000 or whatever be it. And the sample size will vary here. We can go to the other fourth sample is we are comparing here two sample groups. Right? 2 study groups you can see. Study group 1 has a sample proportion of 0.5. Sample group 2 is having a proportion of 0.3. This will be different. Then depending upon level of confidence 95% and 80%, for the population, expected population size, say 1500, the sample size will be 58 here. Suppose I change the population size is 1000. It is from the same population we want to study. Then the sample size is 57 here. So if I change this to 0.4, accordingly, the sample size will change. And method 5 is for qualitative sample. We are comparing with the population. Previously, we are comparing 2 study groups. We are comparing 1 study group with the population here. Again, LOC and power are given. Data, you can give the data any value, 90%, 95%, or 99%. And then population size, you can give it here. I'll give it here, say 700. The sample size is same. So what we will do is if we change it, you will have, so I'll make it as 500. Sample size is 43. Okay. And then method 6, we will see, we are comparing 2 proportions with known standard deviation. So all you need to do is you'll have to feed in the level of confidence, power, and then sample size. I'm just going to put it at 1500. Then it will be, sample size will be 190. Sample size is for study group 1, study group 2. The ratio is 1 here. We can change the ratio also, and then accordingly sample size will vary and the proportion also will vary in the 2 study groups. Method 7 is for the comparison of study group with the population for quantitative characteristic. So here again you are giving LOC, power, and standard deviation for population. Once you give this, depending upon the population size, I'll give say 1000. So 30 is the sample size. So this is how you can use this template. You can verify the values with the manual method and give me your comment, please. Only with this size our sample is constructed properly. This is very important. If it is low, it will not be accurate. The result will not be accurate. Step 3 is choose a sampling technique. We will see 4 techniques in probability sampling. Go to an Excel sheet with say 1000 numbers if population size is 1000. If it is 10,000, you will have to take 10,000 numbers. Then simple random sampling, first technique, you will see. What we do is we are generating random numbers in Excel. You know how to generate random numbers. To get non-repeating random numbers between 1 to 1000. Then pick the cases according to these numbers. This is how you do the sampling. Second one is systematic random sampling. Here what we do is we find out the fraction. Sampling fraction is sample size divided by population size. 200 by 1000, it is 1 by 5. That means we divide the population into 5 each. So get one random number between 1 to 5, 6 to 10, and so on. See, this is the population. I'm dividing into sets of 5. I'm selecting one random number from 1 to 5 and then select another random number 5 to 10. Likewise, I'm selecting random numbers and selecting the sample item, case, collect the sample data. Now, stratified random sampling. Here what we do is the population is divided according to some relevant variable. Please, this is very, very important. We are finding out a variable relevant to the population. Example, you want to study a character of students in a university. Then the students may be day scholars or hostelers. Suppose they stay in the hostel in a single room. 500 people are staying. Total population is 1500. The split up is given here. Staying in hostel in single room is 500. Staying in hostel, sharing double room is 800. And day scholars are 200. So the sample size being 300 out of 1500, we can proportionately calculate the sample size from this category and shared room category and day scholar category. So we are using this formula 300 out of 1500 into 500 is 100. Similarly, for 300 out of 1500 into 800 is 140. And for this year, you'll get 40 here. Now, this is how you are finding out. Finally, cluster random sampling. Previously, in stratified sampling, what we do, we identify a variable relevant for us based on our relevant variable. In cluster sampling, it is naturally occurring variable. It is nothing to do with the population characteristic. Geographical area is such a variable. Little difficult to grasp and justify also. Anyway, we will do this. Population is divided into districts, say 20, and we select any 3 districts. And we have to do the sampling completely in the districts, 3 districts. So sample for district 1, 3, and 5. Okay. Sometimes we can combine these techniques. As often we do it like that only. For example, we combine cluster, stratified, and simple random techniques. We will see here. So this is a state. We have divided into districts. This is a cluster sampling. I'm selecting 3 districts. And then on the district, you can find out the stratified sampling. And each sample, I'm just collecting simple random sampling. I'm doing it. So from this, I'm taking a district. From this, I am taking a strata. And from strata, I'm taking a simple random sampling. This is how you do the sampling in probability sampling. I hope you like this video. In case you like this video, please share it with your friends and subscribe to this channel. If you have any problem, mathematical problem, please mail me. I'll make a separate video for that and publish it here for public view. Thank you very much.